Hello, guys, welcome to this podcast, Everyday Talkies, which ironically does not come out daily. I am Anshul and I talk about random things to random people, majorly about life, perspectives, and thinking process. It's like an interview, or let's say more of a conversation with one or two guests about random topics that interest us. To be really honest, it's just a way to reduce my inhibitions in talking to people. So come join me and enjoy. Hello, guys, welcome to the new episode of Everyday Talkies. So, this is a continuation with the last episode, to the rocket launches episode, where we talked about the space race and the future tourism industry that is going to develop from, let's say, initial space flights to hotels in space or to moon orbits and all of that. So, looking forward to that, but this episode we wanted to touch more on the new innovations that is happening in the rocket industry, in the space industry, what are the new companies that are coming up, and as well as talk about the Indian Space Agency and if there are any Indian companies that are working on it as well. So without any further delays, I welcome back Vivek again, talking about his passionate subject and spreading the knowledge to all of us. But over to you, Vivek.
Actually, I think that was a very different introduction than what I'm used to. My education has been in commerce for the past 7 years. And when you mention that I'm an expert in this field, it actually makes me laugh. Like even Facebook's advertisement algorithm for some reason identify me as someone who would be interested in learning about different technologies which goes into making a rocket.
So now you know Facebook knows you better than yourself and you should pursue your career there. But we'll not go into, this is not that kind of an episode. And education and interests vary very heavily. And there are reasons on why you want to pursue education and things like that. But okay, if people don't know about that side of your life, they should watch our first episode and they'll get to know the whole of you or some of you. So let's not delay very much. So let's begin with the new innovations or the new companies that are trying to bring in new ideas into this industry.
So I'll just ask you a question. Do you think is it possible for you to build an entire rocket from your home? Like maybe suppose you are working for a rocket company which is situated in, let's say, Europe. Can you make the entire rocket just by sitting at your home?
What? A rocket which we launch in Diwali? Yes. A rocket to launch humans? No.
It is actually happening. There's this company called Relativity Space. I'll just go into the background a bit. What SpaceX does is SpaceX print a lot of its engine parts. Like SpaceX uses Merlin engine for both its Falcon 9 and Falcon Heavy rockets, and they 3D print a lot of its parts. So once I learned that a lot of rocket engines are being 3D printed, I was actually searching for what 3D printing is and how it works online. If you ask someone, genius right now, to recreate an engine, F1 engine which was used in the Saturn V rocket, they won't be able to do that because earlier all the construction of engines used to be handmade. The product line was in such a way that you have to pass on a lot of commands manually, and you are developing something and something just didn't fit. So just scribble your notes on a rough pad of paper and you made those changes and you kept that note with yourself because you are the ones who will be working on it for the next 10 years or 20 years. That small notes never made its way into the actual manual log or manual records of how that engine was fabricated. So if you ask someone of an engineer right now, they won't be able to read the blueprints or the manuscripts of those engines, and they won't be able to recreate that. Like my first encounter was with the SpaceX print 3D prints a lot of its parts. Then I came across this company which has its branch in New Zealand as well as in US, and that company is called Rocket Lab. Their main rocket or their flagship rocket is Electron right now, which has achieved I think 12 or 13 launches so far. So they carry small satellites into low Earth orbit, and if they are able to make it a profitable venture and it is a lucrative venture for them, they'll develop more rockets. They are using very lightweight rockets boosters. I think it is made of carbon fiber, which is very light, but you don't lose any of the strength which is required in a rocket. But they 3D print, their entire engine is 3D printed. So when I learned that, I thought this is so exciting and interesting. You can carry the materials in a small box and you can go to Mars or Moon and you can just pass in the command and you'll get any engine you want over there. So this was very exciting. And about a month ago or so, I came across this company which is not only 3D printing their engines, they're actually 3D printing the entire boosters and different parts. I think 95% of their rocket is being 3D printed. So I was watching an interview with one of his founders. That company is called Relativity Space. It is based out of US. He was saying that during the entire phase of the lockdown, when the lockdown was in strict enforcement across US. What it did was all his employees used to work from home. Only there was one supervisor at this factory to ensure that all the parts are working, like all the different segments are working in harmony with each other and nothing goes wrong. So they're 95% like they're printing their rocket through a 3D printer. It is very exciting and a revolutionary change thing in I believe rocket industry.
No, this is actually quite fascinating that you're sitting for a company that is building rockets, that their employees are sitting at home just passing commands over the internet, and the printers are just doing their job. That's actually quite wonderful to think. And like it would be great that to be in a place where it becomes common. Like right now, most of the households have normal printers. It will be really fun where most of the houses will have 3D printers, and these designs will become open source, and different people will be able to come up with their new designs, new ideas, and try to build small parts in whatever small capacity when it will be crowdsourced. So that will be a really good boost to the innovation sector, and that would be something which I would surely be looking for. And some days, who knows, that even us who have no relation to rocket engineering might just become rocket engineers in some way or the other.
I'm actually banking on that. I hope that happens in my lifetime.
Oh, absolutely. Okay, so we talked about 3D printing and all that. Do you have any more companies that are proving their metal in a different way?
I just want to add on the part like the sophistication has evolved so much naturally that almost all the new rocket companies which are coming up, or all the companies which have been in the rocket industry for a long time, all the new engines are being kind of 3D printed. Like I don't think so there's any company which is coming up which is not 3D printing their engines of the rocket. Even there's this company Skyroot. It is the first private Indian company which is planning to send satellites into low Earth orbit. So even they 3D printed the third stage engine, and they tested it, and it was a successful test. Even that is actually very interesting that there's guys from my country who are actually just 3D printing engines, and they'll be sending satellites to orbit very soon.
Okay, yeah. Given that you talked about India now, so why don't we jump into that sector where we talk about how it started, and where are we currently, and what are some of the notable launches, and how are we progressing into future. So initially, I think the hallmarks of ISRO was that with space in India, you usually associate ISRO, the Indian Space Research Organization, and you don't really think about private companies, which we will surely we'll talk about in a while. ISRO, though, is not heard in the world sector that frequently, but it has had its notable achievements quite frequently in the past decade, where starting with Chandrayaan missions and then the Mangalyaan mission, which was quite popular because we were the fourth country to orbit Mars, and we did it so cheaply. Like that was, I think, the talk of the world,
and also the only country to have reached Mars orbit in this first attempt.
Absolutely,
no other country has been able to achieve that. So it is actually very commendable. It is very difficult. Like once you get into the technicalities of how the orbital maneuvers function, and like how you have to change orbital paths and or the trajectories. So it is very difficult. It is a very difficult thing because, as you know, space is vast, and actually get into orbit of a different planetary body in the first attempt is a notable achievement.
Yeah, and then that was in 2013, and then 2017 we had the PSLV launch, the C-37, which basically launched 104 satellites in one launch. That was the highest ever satellite launches.
I think it's still the world record right now.
Correct. It's actually a quite great achievement because you need these missions to tell the world that there is a company, ISRO, which is doing this at such cheap rates, and we are capable of it. Obviously not, I would say, in the forefront of technology given the restrictions that we have, and the restrictions majorly being funding, because as I mentioned in the last episode as well, that NASA has a funding of $18 billion per year, and ISRO has 1/10 of that. Just to give you a comparison, for different space organizations around the world, we have the European Space Agency, which has $7 billion funding. Then we have the Roscosmos, that is in Russia, that gets $3 billion funding. And that might also tell you about the Russian space, I would say, submissiveness, or I don't know.
We can put it in this way: because of the political nature of Russia or the social structure of Russia, there has been economically Russia has not been at the forefront in the world right now. Their technology in space has been stagnant for the past few decades. Even after the space race, like a lot of rocket companies in US still uses engines which are made in Russia by the Russian companies. So like Russia was at the forefront of developing rocket engines and technologies back in the 1960s and 70s, and even way beyond that. After the space shuttle was retired, NASA astronauts used to go to International Space Station and Russian rockets. So Russia has been at the forefront of that.
Yeah, and I think, as you mentioned rightly about the economic conditions and things like that, the funding has been quite low, and that is why we are not seeing any new breakthroughs from the Russian team. But you never know what might come out from there. And then we have China, CNSA, who has $3 billion funding. And at the very bottom rank, we have ISRO at $1.7 billion funding. I don't know why did I ramble so many figures. It's just that I had it written, so I wanted it to be said in the podcast because it did that much effort.
But even with $1.7 billion, what ISRO has achieved is not a small feat. I think it is very difficult to achieve so much of things with such a less funding. I think even like building a flyover or a highway in India takes that much of amount. I might be wrong, but like it seems to me that if you make a flyover which is 120 kilometers long, it consumes a lot of fund.
What will be the cost and what will go in? Okay, let's not go into controversial topics. I don't want to be banned, cancelled, anything. Probably I will save it for some other episode. But yeah, as we were talking about ISRO, and
I just want to point out one thing. I think it will be controversial, but I can't stop pointing out that when you compare, like you were comparing the budget of ISRO with the budget of NASA, and how like small it is compared to NASA's budget. But if you compare to the NASA's budget to the budget of the US defense,
correct, yeah,
like it is actually shameful for humanity that we spend so much of amount on defending ourselves than in exploring. Because if the funding which the US defense gets is the same funding NASA had, in my opinion, I think we would have the actual civilizations on Mars, moons, and even moon of Jupiter and Saturn. Like, this is what I believe, because it is achievable. Just that we fell short of funding. It is not lucrative yet.
I think be it for any country, I'm sure like in most of the countries the defense budget is more than even in India, I would say. Just as you mentioned, it's very shameful that we spend more on being scared of other people rather than exploring the frontiers of space. But okay, let's jump into what are we currently cooking in the ISRO storehouse, and are we looking at privatization of space in India as well? Are we looking at some private companies to do that as well? So what do you know about the current nature of Indian space exploration?
NASA is planning to set up base on moon where water was discovered by the Chandrayaan-1. So I think that is a commendable achievement. And then the next thing to achieve is to send humans to space. So ISRO is developing rockets and spacecraft which will carry Indian citizens to space from Indian soil. That entire project is termed Gaganyaan. So the people which will take off from Indian soil, they won't be called astronauts. They are using a different term for that.
Vyomanauts. But yeah, it's good. Yeah, you get an identity. So, that's always a good marketing trick or whatever. It just gives you a sense of patriotism. So, that's always good. Just to give a quick rundown of the different rockets that are currently in ISRO and what are we looking in the future. So I did a quick research, and I've just did a quick comparison between ISRO, and given that we have such good knowledge about SpaceX, I would like to do a comparison so that people have a benchmark on what they want to look at. So initially we have the small rockets called the SLVs, which are comparable to Falcon 1s and the initial stages of Falcon, which still are for small rocket launches, where small satellite launches which are used majorly for commercial purposes or for defense purposes or things like that. Then we have the PSLV, which as you remember, again a bigger rocket, more in the range of Falcon 9, that basically was used to carry the 104 satellites in space. So we have the PSLV, and there are different variants of that one. And then we have the GSLV. So GSLV is the one which is I think the most powerful one we have yet. I think the most powerful one is GSLV Mark III, which is more like Falcon 9 Block 5, I think. But yeah, I think that is the one which usually we use that for geosynchronous orbits. Okay, these were the basic rockets. I don't know why did I give the rundown. I think the rundown was basically to give a comparison with SpaceX, because as we know that SpaceX is using reusable rockets, right? And it has mastered the art of landing vertically. And for anybody who does not know, ISRO is also working on reusable rockets, because I think that is a fact that all space companies have to look for, because that is the most effective measure.
All the space companies globally are doing that. Even Ariane, I think, is developing a reusable rocket. Blue Origin has the New Shepard, which will take humans to the very bottom of space, like the edge of space. Like that small booster is reusable. And even United Launch Alliance, they are trying to develop reusable rocket. Because if you have to survive in this industry, you'll have to start making reusable
Absolutely.
rockets.
And I think that is where I think India lacks a bit, because SpaceX has cracked the formula. Similarly, other companies have and are in the breakthrough. ISRO has not yet got the formula right yet. It is currently developing the RLV series of rockets, which is basically it was tested in 2016, where they are basically experts in horizontal horizontal landing now, which, as you mentioned earlier, like space shuttle, like the airplane landings that we have currently. Yeah, they've managed that, they've expertly tested that, but we want to get something which is vertical landing, which is more efficient, which is more cost effective. So that is something which India is working right now, and hopefully in the future we'll get to see that soon as well. And I think to basically sum it all off and talking about the private agencies, the private space agencies, I have a few names that come at the top of my head, and something which I remember is this is a very good, first of all, YouTube channel which I would like to shout out, which they do a regular update on the Indian space research systems and the different space agencies that are there. Garib Side. So he does a lot of videos in Hindi talking about the Indian technological industry, more specifically in the Indian rocket industry and the space agency. So shout out to them, and you should check them out. From that video, I got to know that there were multiple companies, starting with Skyroot Aerospace, which is I think the most prominent ones, based out of Hyderabad. So they're actually they comprise of former ISRO scientists who are developing a series of rockets called Vikram 1, 2 and 3, and they're basically trying to commercialize sending of rockets into space. Nothing has been heard yet. They're not publicizing it until and unless we're successful. I think that is the Indian mindset when it comes to space agency. Until we're successful, we don't really like to beat our drums. So looking forward to learning more about them. And the second one which comes across is Agnikul Cosmos. They're based out of Chennai, and as you mentioned, they are working on Agniban, which is again a two-stage rocket, and they have 3D printed engines, which you had mentioned earlier.
Actually, I think we should also learn 3D printing, and we can. I think we can start our own rocket company. We'll start a crowdfunding. Podcast will get popular and we'll get crowdfunding, and then we can just make our own rockets and go to space ourselves. We won't have to rely on Virgin Galactic or Blue Origin or SpaceX to take us to space.
I don't know how much confidence you have on yourself, but I don't have any confidence in anything that I have built. I can risk my life on the rockets that I have built in my backyard to go into space.
No, the thing is, the worst thing that will happen is it will fail. So I think that's not a problem.
The failing of rocket is not a problem, but losing life might be a problem for some, I guess. But let's not get into that.
Yeah, okay. Also, I think you mentioned that Indian companies are coming up with rocket and they're integrating rocket technologies over here. I just like to mention there's this kind of dark horse which is being overlooked by everyone I know. It is very difficult to learn about them. They are based out of Syria, Nevada. I think their name is also Syria Nevada Corporation. They are not only developing that, they are developing kind of spacecraft which will carry humans between Earth and the Mars, like between the orbit of Earth and the orbit of Mars. It won't take off or it won't land. It is actually very efficient. The design is very efficient. It looks more like a Starship Enterprise design. It has been designed in such a way so that the journey between the orbit of Earth and the orbit of Mars is very comfortable. And they're even developing landers to land on Mars. That lander will be separate. It will be in orbit of Mars, and it'll go along with that spacecraft, and it'll undock and then land on Mars. So their sole purpose will be just to carry and just to land. That is very different from the approach which SpaceX has adopted, because SpaceX just wants a single purpose vehicle which can do everything.
Talking about these different ventures and the different approaches to space travel, one thing which comes to my mind is an Indian company called Bellatrix Aerospace. They have a very different approach to rocket launches. They are developing something called a mobile launcher. So a rocket which is mobile, so you could be launching from Kolkata to Bangalore, anywhere. So that's a very different concept, something which is cost effective, which is not restricted to one particular location. I don't know how are they doing it. So, something which we should look out for.
Like you mentioned mobile launches, I was actually reading about it. It was developed by both Russia and US, and I think they had a few launches as well, where they used to launch rockets from the deck of a ship. It is kind of a mobile launcher, but it used to transport on sea. The benefit of this was that you could take it near pole, or you could take it to equator, and you could launch rockets from there. So if you want an orbit which is aligned with the equator, you won't have to spend too much of fuel on maneuvering your rocket or the third stage of the rocket or the satellites to get into that orbit. So those are the technologies they didn't dwell too much into because that I think that are not cost effective, or they just didn't want to invest too much in that.
I'm just glad that there are so many innovative ideas happening at once. There is suddenly a space boom, I think, which was basically, I would say, popularized by the emergence of SpaceX and how people got heavily invested in that. I remember when the Crew Dragon was happening, when the launch was happening with the two astronauts who were testing the flight too. Then that I think there were around, if I remember correctly, 200,000 people watching a live stream in YouTube. It was such an amazing feat.
Today in the morning I was watching this rocket launch by United Launch Alliance, the Delta IV Heavy. Unfortunately, it was an abort because their engine didn't ignite. Like I follow this channel on YouTube called Everyday Astronaut, and there were 20,000 people watching that. And this was just a regular rocket launch, which was carrying a regular payload for the US government, and still there were so many views. And actually this weekend there'll be multiple launches by SpaceX. SpaceX will be launching two Falcon 9s. Then there's one launched by Rocket Lab of the Electron rocket after such a long time, and then there's one more launched by Ariane, if I'm not wrong, by the European Space Agency. So like there are multiple rocket launches by multiple companies. Like so many rocket launches are happening on a single weekend. It is too exciting.
Yeah, and I think one thing which should be mentioned is, and I think probably the Indian government should take note of, is that how these different companies are also marketing them very beautifully. Like you see, there are extra effort to put cameras outside so that people have that view of how the rockets are performing, how are they working. So I'm sure the Indian governments have to probably enhance their cameras and market these on YouTube, on these different social platforms, so that people can collectively view it as an occasion and celebrate it.
I think the private companies which are coming up, they'll do that because they know the importance of this.
Absolutely. We have discussed quite a lot in this episode as well, where we delve into amazing innovative ideas of different rockets and the Indian space research. I think this topic is never ending, and probably every time we do this episode, we will just say that we have just scratched the surface. There's so many things happening, some things that we are unaware about, and as and when we get more information, probably we'll do a new part of this episode. Who knows?
Maybe next time we come on this episode, we'll have our own rocket company. Come on,
wow,
Anshul.
Wow. Yes. Well, we'll try our level best. But till then, thank you everyone. And before going, I would just like to end this episode on a quote from Vikram Sarabhai, our father of Indian space exploration. It was a quote during his time, still I think relevant today for the Indian space research. So I would like to close it by that. So as he mentioned, there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or the manned space flight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technology to the real problems of man and society. That's such a beautiful, I think, message to probably end this episode on. Thank you, Vivek, for gracing this episode with your knowledge and being in this episode again. Soon we'll have you back with the next episode with a different topic. Till then, thank you everybody for joining. Bye-bye.
Bye-bye.
Thank you to all the listeners. I'll catch up with you again soon with someone new and lots of interesting discussions. So, bye.